Alright, let's get started with the first problem of the day, which is going to be LeetCode number 49, Group Anagrams. Given a string strings, group the anagrams together. You can return the answer in any order. Okay. An anagram is a word or phrase formed by rearranging letters. Okay. Yeah, you know what an anagram is. Not gonna lie, kind of feels like union find, where we're finding disconnected, forgot what's the phrase, disconnected, or finding connected components, I guess, maybe. So the idea is that we start off each one as its own anagram group, and if an anagram group has the same letter frequency as another, then we connect them, and then at the end we mash them all together. We know that the string's length is less than or equal to 10 to the 4, which seems to indicate an O of n squared algorithm, maybe? Actually, no, that would be insane. Probably an O of n algorithm then. Maybe n log n or something in that neighborhood. Definitely not not n squared though. Not n squared. N squared would be 100. Let's see. So how could we interpret this as a union find problem? Well, start by having, well, we'll have a node. This node will have a root of node non-nullable, and then a frequency, which is a map of characters to integers. So we'll start by creating a node of all strings in strs. I'm gonna call it strs. Then for each node, if compared to all other strings, if the frequency map matches, then we can chain them together. Let me think. And how do we want to chain them together? We will probably have a map which maps a node to a list of nodes, which will be our chains, and remove the other element from our list, or from our map. So we want to remove that element from our map after we check that. So this will be an O of n algorithm to create the nodes. Then chaining them together, that is a good question. Let me think. I guess the bonus here for runtime, I guess we could argue that if a node does not match with any other node within the list, then we know for sure that it is within its own anagram group. With this node, we'll also, yeah, we'll need a, this will probably be a parent rather than a root. I think that makes more sense. Though if we want to actually make it n log n, I think we actually need to do the shrinking thing where when we connect the components, the roots together, we collect a list of all the components or all the parents in the middle, and then we all link them to the root itself. And then finally, for each node, so this could potentially be O of n squared. So I want to come back to this. For each node group within the chain, create a list of the values. So we'll need a value, which is a string, parent, which is a node, and a frequency that matches. Create a list of the values and return. So this will be O of n as well. Just going through because we would have, well, we would need to include all the elements within the original array, so we can't get better than O of n there. Union fine though, I do wonder if it's fast enough. I'm gonna be honest, I can't really remember the exact runtime of union find, but I think it makes sense to use it here because of the context of connecting finding connected components, right? We'll see. I think we can code it up and we can think about it a little bit more. What if we did something different? So rather than comparing against all the nodes, within any given list, only compare against the roots within chains. So within the chains map, we are only comparing the nodes to each other, essentially. That might work. Yeah, I think that'll work. The first one will take But I know that the map, or any mutable really, any mutable structure is fickle to the for each loop. So we'll probably have to use a for. Use a queue. We could also try to use a standard for loop rather than a for each loop. That might satisfy Kotlin's concurrent modification exception. Though the for loop only runs once, right? The collection of objects within the for loop only runs once. Which, now that I think about it, is probably fine. So let's go ahead and start coding it, and then we'll see if we run into any issues along the way. So we'll have to start by creating a data class node, which has a value string, a parent, which is of type node, and a frequency, which is of type map from character to integer. Then here we'll have to create a chains, which is a mutable map of node to list. This will be a mutable list of nodes. Then we can say stirs.forEach. So this is this is going to be the only, so this will be the build phase of the union find. So we build up the individual roots. So we do chains.put. Well, we'll first have to build up a frequency map, right? Mutable map of char to int, and then string.forEach character, frequency map get or put into the character, or we put a 0 there, and we do frequency map put in we do the character as a key and get our put +1. This needs to be a lambda. So we either get the value within the character, or we add, or we default to 0 and then we add 1 to it. Then we can say chains.put a string, well, a node which has a value of string, which has a parent of, we'll have to create the new node outside, or could do this. Is it possible to default like that? So value is equal to string, and frequency is equal to frequency map. Let me see if this compiles first, because I am list of list string. Oh, this is a val string. This is a var parent. This is a val frequency. This is not defined in this context. Okay. How do I reference this self? Maybe if I do an init and I say this dot parent is equal to this. I don't want to make node nullable, but it might be required to make it nullable. If I do this, and then I do string null, and then frequency map, will this solve the issue? Value, which is a string, parent, which is a node, frequency. Oh, list of node, which is empty. Or mutable list of. And we did a Stack Overflow error. Let's see. Let me check. This expressions. Okay. That doesn't really help here. We can do a val new node is equal to node string null frequency map. And then we can say new node dot parent is equal to new node. I guess that's one way to go around. Doesn't feel very nice to be reassigning it and having it be nullable, but it works. Then we can say for let's see. Entry, which is of type entry in chains. Does this work? Or what if we just omit the type? Looks like omitting the type worked. Running into a TLE. Unfortunate. So we do that. Then let's see. What if we did a chains.for-each, just like in general? Entry, line, entry. Or is this just too slow? Interesting. How fast is union find? We should be fine with union find. Maybe it's the print line that's let's see. For index in 0 to chains dot size -1 for next indices in index +1 to chains dot size -1 if chains at index dot frequency is equal to chains at index or new index dot frequency. Then we can do chains dot remove. Well, first we want to do chains at new index dot frequency. It should be a var. That's a map. Oh no, not frequency. Chains at new index. That provides an entry, right? Let's see. Do I even really need this data structure? I think I do. Because the union find or the disjoint data disjoint set only goes one way, right? It goes from child to parent. But there's no way to really know sort of the groups afterwards. Let me see. But we want it to be fast. Let me think. Because chains at new index would get the value. Let's see. Because I need the actual node. think. What if we didn't use union find? Or we didn't use union find in that way. So what if rather than creating an entire node there, we created a mutable, or rather just a map of characters to integers? Which had a mutable list of strings. And then we said that what we can do is that if chains dot put into our frequency map, our chains dot get or put at our frequency map, or if there's nothing in there, a mutable list of string which needs to be a lambda, dot add string. This might count as complex expression. Inferred type is Boolean. Where is the inferred type Boolean? We'll call this chain list is equal to chains get or put frequency map mutable list of string. Chains. Oh. Whoops. The heck happened here? No, this is fine. Actually. Yeah, it's a map of characters to integers. As our key, and then we build a mutable list of strings. Oh, because it's that. I think that should return the actual new list. Type inference failed. We can just have this as a list, that's fine. Or actually what we could do is just do chain list.add string. And there you go. Let's see. That, and that. Okay. And then we just do return chains dot chains dot toList or map. Can I translist transform function to every? Can I just do it like that? And then we have an entry. We map the entry to entry.value. So basically we just squash it. Okay, cool. That seems to have worked for one of the examples. We could probably speed this up also by saying like if strings dot size is equal to 1, which is the minimum, we just return a list of list string, which contains a list of as strings at 0. And that should also work. Cool. Okay, let's throw in a submit and let's see if this works. But yeah, I might have been way overcomplicating it with union find. I think that it is still possible to do with union find. I think it is still very much possible to do with union find. Though it might be slow. I don't know. This works, but it's still pretty damn slow. Let me think. How could we speed this up further? Frequency map. List. Could probably do like a linked list here. I'm not sure if that would be faster or not. I don't know what's the underlying structure of the mutable list within here. Actually, I could probably check it out, right? If I search up mutable list, what is the underlying data structure that it uses? Because mutable list is an interface, so when I create it, what does it actually what does it actually default to? Does it actually default to an array list? If it does, then there is merit to say that if we use a linked list instead here, that it might be a little bit faster. Because a linked list is default O of 1 insertion at the end. Whereas the mutable list, if it is truly an array list implementation, then it would be amortized O of 1 insertion to the end, but not by default, right? We need to keep this as a map data structure. There's no way around it. We can't use a set or anything like that, and anything else would be actually be probably slower. Yeah, let's see if this is faster. Though I'm not sure, can a linked list just go ahead and map to that? It can, okay. Let's see if this is faster then. Standard O of 1 versus amortized O of 1. Slightly faster, but not by much. Okay, in that case, there's probably a faster way, but I'll check that out in my own time off camera. But in any case, I hope you learned something. So this ended up being a pretty straightforward implementation. You might be able to get faster time with union find, maybe, maybe not. But in any case, I hope you learned something, and I'll see you for the next problem.